Here is my SR gates, my SR latch using a NAND gate. This IC in the middle is the NAND gate. VDD and ground are connected according to the datasheet on Blackboard. This wire, this input actually is the set input, while this one right here is the reset input. This LED is the Q0, and this LED is Q. Resistors are act as the in-betweens between the output of the NAND gate and the LED in order for the LED not to burn out. And as the second inputs, so the second input for the set part of the NAND gate is gonna be the output of the whatever the reset. I guess like if you consider this gate as N2 and this output as well, actually this input as output as N1 and this output as N2, then the output of N1 is going to be the combination of the input from set and the output from N2, and the output of N2 will be the combination of the input from reset and the output from N1. And since this is a NAND gate, that means not AND, so anything that is not 1, 1. Now, when we turn the power supply, you can see that the as set is equal to 1 and reset is equal to 0, Q0 is set to 1. When we switch reset to 1 and both S and R are equal to 1, there is no change of state, meaning that the current output is equal to the previous output, which is why Q0 is still equal to 1 and Q is equal to 0. Now, when we switch S to 0, then Q becomes 1 and Q0 becomes 0. And likewise, when we set S back to 1, there is no change of state, meaning Q is still outputting a 1 and Q0 is still not outputting anything. There's one more situation we haven't checked, and that's because that's known as the forbidden state. When we set both S and R equal to 0, then both the Q0 and Q become 1, which is not supposed to happen.